So this is code I had, which draws an object, which is a square. We have stored the coordinates of each corner of a square in an array, a double array of floats. Each point is a row of 3 floats. And similarly for colors, we're storing red, green, and blue in an array. And at the end of the last, and so then we'll ignore this for now. At the end of the last video, I introduced that. I told OpenGL I was going to send it triangles, and then I looked up the value for the color and the coordinates of each vertex in those arrays. And I told you that there was a way to essentially skip all of this and just pass these arrays right into OpenGL once I introduce this array of indices of the corners of the face. I.e., so this one, you draw this face as corners 0, 1, and 3, and this face is corners 1, 2, and 3, so you just store those indices in this array. And here's how you do it. So OpenGL has the ability in it to there's the concept of a client and state versus just a general state, and this is the idea that you might have a whole bunch of workstations all sharing the same graphics card somehow. I don't really think that's how I know of it being used very often anymore, but you have to enable something called the client state, and you're going to tell OpenGL that you're going to be passing the colors in an array. So you have to enable color array, and you also have to tell it that you're going to be passing the vertices themselves in an array. So vertex array. So that's basically telling OpenGL that we're going to provide it with the pointer to the beginning of this array and the pointer to the beginning of this array, and it'll be able to use those to automatically color the vertices of our object. The only caveat is the color array and vertex array, their format. It needs to know that this is made out of floats and that there's 3 coordinates per point instead of maybe 2, for instance. So once we've told it we're using the vertex array, then we specify the vertex pointer. So there's a command GL vertex pointer. The first thing is the number of coordinates per point. If you want some help in Qt Creator, you hit F1. So it wants the number of coordinates per vertex must be 2, 3, or 4. We're going to do 3 coordinates per vertex. The type, we're using floats, so we say GL float. The stride, so it might be the case that there's other things besides just the vertex coordinates that are stored in the same array. So it needs to know how many bytes it needs to skip to get from the beginning of one vertex to the beginning of another. You can just pass in 0 if the only thing in your array is the vertices. And the final thing is the pointer to the beginning of the list, which is just vertices, the array itself, right? And we need to do a similar thing for colors. So there's a GL color pointer, and it takes in similar arguments. Let me press F1 to see what they mean. You can see half of that on your screen. I'm looking over here. For a color, the size must be 4, which means that we have to have an alpha channel. So I'm going to add the alpha. I'm going to draw everything opaque, which means that each element now has 4 floats. And so when I pass the GL color pointer, that must be a 4. I'm storing these things as floats, and the stride again is 0, and the pointer V colors. So now I have OpenGL knows about these arrays, and it knows that I'm giving it vertex coordinates and vertex colors. So here, instead of GL color 3FV, I can use the statement GL array element and pass in 0. And instead of these two statements, it's automatically going to look up the color and the position of point 0 and pass that in. If I run it now, we still get the same square. It looked them up, right? So I can replace all of these things with calls to GL array element. So I can say GL 0, 1, 3 and get rid of those. And for here we've got 1, 2, 3. So I can get rid of all of this and have GL array element 1, 2, and 3. And is that right? Yep. So if I run that, it draws the quad. So I've reduced a lot of code by setting some OpenGL state in terms of I'm telling OpenGL where my array of coordinates lives, where my array of colors lives, and I'm telling it here that I'm using colors and that I'm using the positions. So it automatically knows what statements to issue for each array element. Which is fine, but I told you we'd be able to get rid of this whole chunk. So there's another command, GL draw arrays, and I deleted that. That wasn't what I wanted. I wanted GL array GL draw elements. There we go. GL draw elements. And I pass it the mode, which is this. I want it to use the indices here. I'm going to pass in these indices, and it's automatically going to issue all of these statements for me. So I'm going to tell it to do triangles, and that there are going to be 6 things coming in. That they're ints, and then I just pass in the. Actually, I can't pass in int unsigned short, and I'm going to have to go back and edit the type for faces, and then I just pass in faces, the pointer itself. So I had to look at the help to figure out that that this can't be an int; it has to be declared as an unsigned short, which makes sense. Your indices can't be in your array. You can't hold an array that's too big in memory. So here we have unsigned shorts, and this statement should replace all of those. There we go. So we are now completely drawing the mesh by simply informing OpenGL of an array of vertices at the corners, and then also an array of indices of which vertices need to be connected to form a face. This is an indirect mesh because the vertex coordinates and other properties are looked up in an array, but it makes it really easy to avoid duplicating vertices that appear in multiple corners. It saves you memory, and it makes it easier to keep things continuous. Not only that, but this technique for drawing objects using these vertex arrays is more efficient. It's often faster.